Okay, and we're going to look this morning at solving the addition of two vectors. So if we take one vector that's going at this angle, okay, we'll give this a theta equals 30 degrees. And remember, the 30 degrees is from the horizontal to the vector, okay? And we'll say it's a 30 degrees and we'll give it a value or magnitude of 40 newtons. We want to add that to a second vector, okay, and we'll describe this vector at a magnitude of 60 newtons, and we'll give this angle theta angle. Remember, it's from the horizontal, from the x positive, okay, and its theta is 135 degrees. And it's worth noting maybe that we should always display our positive x and positive y axes. So if I put them two up as positive x and positive y axis. So just a quick revision. What we do to add these two using analytical methods is that we're going to solve the x component of each vector and the y component of each vector. And we should remember that f, the force, the vector force x component, is equal to f cos theta, and the force y component is equal to f sine theta. So these are two important formula that you should know in order to determine the x and y component. What we mean by the x and y component of the vector is that we have the vector coming up here at a certain angle, theta, and its x component, positive x component here in this instance, and this instance is a positive y component. So this is f, and this is fx, and fy. These could be going in positive or negative directions. In this case here, both of them are positive. So this would be the x component of this force, and this is the y component of this force or vector. Okay, so looking at this first one here, if we get the fx is going to be equal to the force, which is 40, times, okay, the cosine of 30 degrees. Put that inside a bracket. Okay, and that would be equal to 40 times the cosine of 30 being 0.866. Multiplying the two of them out, we will get 34.64, and force again is newtons. The Fy of this first vector will be again the force, which is 40, times the sine of 30, and that will be equal to 40 times the sine of 30, which is 0.5, and multiply those two out, we get 20 newtons. So we already have the x component of this vector and the y component of this vector. So it's vector 1 done. If we jump on and do vector 2, we'll have fx again is equal to this time 60 multiplied by the cosine of 135, and that's equal to 60 times minus, this is very important, minus 0.707, and that's equal to a minus direction. Okay, so it's a minus 42.42 newtons, and that tells me that the x component in this vector is actually going in this direction, a minus direction. So it would be in this direction here. Okay, and that's why it's minus. So remember our plus and negative from earlier on. And if we look at the fy here, for the second one, we have 60 times the sine of theta, which is 135 again for this vector, is equal to 60 times it's actually the same here. 0.707. Okay, but this time it's a positive 707. And that is equal to 42.42 newtons. Okay. So what we do now is we just basically add them again, add them together. So we're going to add the x and the x and the y and the y. So we basically have, there's this over the side here, fx1 plus fx2. Okay, and this is fx1 here, fx2, xy1 and xy2. So we could have that 34.64 plus 42.42, and that is equal to, sorry, it's a minus 42 there. So our actual answer would be minus 7.78 newtons. Okay, and then Fy1 plus Fy2, add them together, and we get 20 plus 42.42. Add them together, and we get our 60.42 newtons. All right, so we have our two components, but these are just two components. So we're basically left with an x of minus 7.78 and a y of 60. So what we have to do is we have to get a resultant magnitude of these. So what we can do is we can best describe these maybe as our y is in this direction and our x is back in this direction. And we need to determine our force, okay, which will be going, our new vector, which will be going up along here. Okay, so we have this and have this, our x and our y. And we need to find that. So we can do that by basic trigonometry, where we just basically draw, okay, our x component, which you know is minus 7, okay, and our y component, which we know is our 60. Okay, and what we're trying to do is we're trying to find out this length here as such. So we know this here is 60.42, and we know the bottom here is minus, it could be it doesn't matter, it's minus 7.78. And what we're just trying to do is we're just trying to solve for this triangle, okay? And we can simply using Pythagoras' theorem to find that out, okay? So obviously the square on the hypotenuse is equal to the sum of squares on the other two sides. So what does that mean? So we're trying to find for, let's call it x here a second. So the square of the hypotenuse, x squared, is equal to the sum of squares on the other two sides. So it'd be 60.42 to be squared plus, it's minus 7, but again we'll square it, so it'll be a plus 7 in a second to be squared, okay? And we add them together, we can take that over and bring over the square root.